Now recording. Whoops. Here we go. All right, so we're still pretty much on schedule. Doing more trig 6.3. And after I think I've done enough, then we'll stop and do our quiz. The quiz is not on any trig. The quiz is on exponential and log functions, as I mentioned. So our usual quiz day, I'll break you into breakout groups of 3 or 4 or 5 or something like that. And as usual, put your first and last name and first and last name of everybody else in your group. And then I'll look at all of them, but I'll grade only one of them. Okay, so the only way to be sure to get full credit is to make sure everybody in your group has it correct. And of course, it doesn't matter who I decide to grade, then you'll get full credit on the quiz, okay? And looking ahead, the exam again is on Thursday, the 18th. It's not going to be next Thursday. I'm moving it back to the 18th. Coverage is chapters 5 and 6. So as we've been doing 2 chapters at a time. So chapter 5 and chapter 6. And we're almost done with chapter 6. So we're not quite done, but probably by early next week, we'll be done with everything you need for the exam, okay? All right, so I'll get going with 6.3, and we'll see how it goes. If it gets near the break time and I think I've done enough, I may decide again to just go ahead and forget the break, just keep going and then stop and then just go straight to the quiz, in which case during the quiz you can break, as necessary, and then it'll be over faster, okay? All right, so 6.3. Okay, the assignment is 1 to 51 odd. Let me show that to you for those of you that aren't getting the book. It's on page 451. Okay, so here's that. Some more there. 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 And you had to go up to what, 51? And there's 51, it looks like. Okay. All right, so we're all there. Okay, 6.3, we're switching to something called the unit circle. Okay, we're not completely abandoning the right triangle that we had before. Okay, it's on page 441, but you want to get used to something called a unit circle on page 442. Now they're giving you all this other stuff. I'm only going to give you what I think you need. Okay, unit circle, the equation is x squared plus y squared equals 1. You can put that on your cheat sheet if you wish. Okay, it's a circle centered at the origin with a radius of 1. You've done some of that in your algebra. Okay, circle centered at the origin, radius of 1. Now, we're going to define something as an angle in standard position. Okay, so I'm on page 442. So when we have an angle in standard position on a unit circle, here's my unit circle, x squared plus y squared equals 1, center of the origin, radius of 1. Okay, we're going to start going to the right. So this is considered 0 degrees. Why do we do that? Because we said so. That's pretty much it. We could have started here, we could have started here, but by convention, we've all agreed we're going to call this 0 degrees. And then a positive angle is going to be counterclockwise. So this way is considered positive. Again, that's by convention. We decided to do that. Okay, so this is considered 0 degrees, and then I go this way for a positive angle. So this would be 90 degrees. This, as you can see, is 120 degrees in standard position. Now, if I go the other direction, clockwise, this would be a negative 120 degrees. Okay, so notice pointing to the right is we consider 0 degrees. If I go this direction, that's 180 degrees. If I go backwards, that's a negative 180 degrees. Notice it lands you in the same spot, of course. Okay, so by convention, 0 degrees is considered to the right. Positive is counterclockwise, going this way. So this is 90 degrees, 180, 270, 360 degrees by convention. Going backwards, going this way would be negative 90 degrees, negative 180, negative 270, negative 360, going that direction. Okay, so here's an angle, they call it theta. Okay, if I go a certain angle, we land at a certain point, they call it x comma y. Okay, all right, so let me show you this picture in figure 5. Okay, and let me check something quickly. All right. Okay, let's take a look at this picture. Here's an angle theta in standard position. They've got x, y, and 1. 1 is the hypotenuse, as you can see here. All right, now let's think of our SOHCAHTOA stuff. Okay, so if I do SOHCAHTOA, sine is opposite over hypotenuse. Y divided by 1. But what's y divided by 1? Y. Okay, and how about cosine of theta? Cosine of theta is adjacent over hypotenuse. That's x over 1. But what's x over 1? Just x. Okay, so that leads us to these, and you can put this on your next cheat sheet if you wish. Definitions on page 442. Okay, on a unit circle, this is a unit circle. Okay, the cosine of theta is just the x coordinate. The sine of theta is just the y coordinate. Their ratio is the tangent. Look back at this picture again. Tangent of theta is opposite over adjacent. Okay, so opposite over adjacent is y divided by x. Okay, so tangent of theta is y divided by x. You may also realize it's the same as the sine of theta divided by the cosine of theta. That will be a definition that we'll use later on. Okay, I'm going to sneak that in here. Whoops, maybe I should write that in red. Sine of theta divided by cosine of theta is equal to the tangent. Okay, so on a unit circle, the x coordinate and the y coordinate are cosine and sine. You can put it on your cheat sheet. If we were meeting face to face, I'd make you memorize it. If you had to memorize it, an easy way to memorize it is that it's alphabetical order. X is before y in the alphabet, right? And cosine is before sine. Okay, so x comma y is cosine theta, sine theta. These are the same reciprocals as you had before. Reciprocal of cosine is the secant, so 1 over x. Reciprocal of the sine is the cosecant, 1 over y. Reciprocal of the tangent is the cotangent, x over y. Okay, but you can put all of this on your next formula sheet, on your next cheat sheet if you want. Okay, so cosine of theta is x, sine of theta is y. The ratio is the tangent, y over x. Okay, again, you can put all this on your formula sheet if we were meeting face to face, or maybe the next time or the next math class you take, maybe by then we're back on campus and your next teacher might make you memorize stuff. One way to memorize this to me is you already know the formula for slope, really, right? Slope is y2 minus y1 divided by x2 minus x1. So which is on top? Y. Which is on the bottom? X. So that's kind of like that, right? So which should go on top, the y or the x? Then just remember, oh, slope. Slope had the y on top, x on the bottom. You've already had that memorized in theory. So tangent of theta is y over x. Okay, so I'm doing a little juggling act between, you know, helping you out this semester, but in a future semester, maybe your next teacher's going to make you memorize all this stuff. Okay, so just thought I'd warn you. Okay. Okay, so here's a nice table also on page 444. Okay. Now, technically, you can get all this on your calculator, but how do you do it without a calculator? Okay, and yes, same thing. If we were meeting face to face, I might not let you have a calculator for working this out, and it might not let you have this table either. Okay, but if you take a look at this unit circle, think of the unit circle. Here's 0 degrees, 90, 180, 270, 360, multiples of 90, right? Now, as an ordered pair, what is this point? This is 1, 0, right? In fact, I think I'll just go ahead and write it in. It's a unit circle. This point is 0, 1. They tell me this is -1, 0. This is 0, -1, right? So cosine and sine of the angle are just the x and y coordinates. Okay, so watch for cosine and theta. Look at the x coordinate as I go around the circle. X coordinate 1, 0, -1, 0, 1. 1, 0, -1, 0, 1. Okay, just the x coordinate. Look at the y coordinates as I go from 0 to 90, 180, 270, 360. Y coordinates 0, 1, 0, -1, 0. There we are. 0, 1, 0, -1, 0. Tangent is y over x. Well, this is x, this is y. I just divide. 0 divided by 1, 0. 0 divided by -1, 0. 0 divided by 1, 0. 1 divided by 0 is undefined. Likewise, -1 divided by 0 is undefined. That's why these are undefined. Okay. Reciprocals. Secant is a reciprocal of the cosine. What's the reciprocal of 1? 1. What's the reciprocal of -1? -1. 1, 1. 0 has no reciprocal. You can't go 1 over 0. Undefined. Undefined. Same logic for sine. 0 has no reciprocal. Undefined. 0, undefined, 0, undefined. Reciprocal of 1, 1. Reciprocal of -1, -1. Cotangent. Well, if tangent is y over x, cotangent x over y. Okay, and go ahead and write here secant is 1 over x. This is 1 over y. I'll let you put that on your formula sheet, although this is the same thing as what I put over here also. Where did I have it? I had it here somewhere, right? I can just turn the page. Oh, these things over here, right? Okay, x over y, 1 over 0, can't do it. -1 over 0, can't do it. 1 over 0, can't do it. 90 degrees, 0 over 1, 0. 0 divided by -1, still 0. Okay. Now, here's a real nice picture of illustration on page 445, okay, to give you an approximation of sines and cosines, okay? Yes, you could get all these on your calculator, okay? But this gives you visually, suppose you were not allowed a calculator, okay? Maybe your next teacher won't let you have a calculator, okay? So do you want to put this on your cheat sheet? It's up to you. I mean, it's not very easy. I guess you'd have to make a photocopy of it, okay? This is supposed to be 1, 0, 0, 1, -1, 0, 0, -1. These are all tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's like 0.1, 0.2, 0.3, and so on, okay? Likewise, that's 0.1, and this is -0.1, -0.2, and so on, okay? So if you want the cosine or sine of an angle, you're just looking for this x or y coordinate, as the case may be, okay? All right. On page 446, reference angle. Okay, unfortunately, the pictures that they give don't illustrate all the possibilities. So I'm going to make up my own picture. And what they have is correct, but it doesn't illustrate every possibility, in my opinion. Reference angle. Let theta be an angle in standard position, and suppose that theta is not an integer multiple of 90 degrees. That means it doesn't land at 90, 180, 270, 360. The reference angle associated with theta is the acute angle. Acute angle is a positive angle between 0 and 90 degrees, formed by the x-axis and the terminal side of the angle theta. Okay, so what does that mean? Okay, so I'll show you an angle in each of the 4 quadrants. I'm sure you've heard of the 4 quadrants before. Quadrant 1, 2, 3, and 4. Okay, so what they have is correct, but I don't like how they don't show you an example in each quadrant. Okay, so I'm going to talk about reference angle now. Okay, reference angle. Oops. Reference angle. And by the way, I may abbreviate angle with a tiny little angle-like thing right here. Okay. I'll show you an angle in each quadrant. This is quadrant 1. Okay, here's theta in standard position, quadrant 1. Now, by definition, we take the given point and go back to the x-axis. So in this case, the reference angle is the same as theta. So reference angle is the same as theta. Okay. That kind of makes sense. If you're in the first quadrant, we already like it. The reference angle is the same as theta itself. Okay. Let's look at the definition though. It's an acute angle. Acute means less than 90 degrees, but positive, formed by the x-axis and the terminal side of the angle theta. So what does that mean? All right, so if you're in the first quadrant, the reference angle is the angle itself. So let's say this is 50 degrees. The reference angle is 50 degrees. Okay, best case scenario. Now let's look at all the other quadrants. Quadrant 2. Here's the angle theta. What's the reference angle? This is more than 90 degrees. You want an angle formed by the x-axis and the terminal side of the angle that's less than 90 degrees. So that would be this. Okay, so what's the measure of this angle? Well, if I go all the way here, that's 180 degrees, right? This is theta, so this must be 180 degrees minus theta. Okay, so the reference angle is 180 degrees minus theta. Sometimes I write angle, sometimes I write this. Okay, so if you're in a second quadrant, this is my reference angle. Okay, third quadrant. So let's say we're over here. Theta. Okay, again, the angle in standard position starts off with 0 pointing to the right, and we go counterclockwise. 0, counterclockwise, 0, counterclockwise. Okay, what's the acute angle made with the x-axis this time? Right here. So how do I find that? Well, this angle is 180 degrees, right? I throw out 180 degrees from the given angle. So this is going to be theta minus 180 degrees. So in quadrant 3, reference angle is theta minus 180 degrees. And finally, quadrant 4, which is over here. Okay, if you want to put this on your next cheat sheet, you may. Okay, fourth quadrant angle. over here. Standard position. Here's quadrant 4. Okay. Quadrant 1, 2, 3, and now 4. Here's theta. Again, in standard position, we always start with 0 this way, and positive is counterclockwise. All right, so the reference angle is the acute angle between 0 and 90 that this ray makes with the x-axis. This time, I want that angle as a reference angle. Okay. Okay, so what do I do in this instance? Well, if I go all the way around, that's 360. I'm just losing this piece right here. So I subtract that off. So that's 360 degrees minus theta. Okay, so the reference angle is 360 minus theta. So here are the 4 cases that we have for reference angle. Now, in my opinion, if you understand the concept, you don't need to memorize or write down these formulas, okay? Just look at the angle and come back with an angle between 0 and 90 degrees that touches the x-axis, okay? So here we go. First quadrant, the reference angle is the angle itself. Logical, best case scenario. Second quadrant, it's this angle, which is 180 minus theta. Third quadrant, it's theta minus 180. Okay, because you want this. How do I get this? I just subtract 180 from the theta. And how do I get this reference angle? If I go all the way around, it's 360, and I back off this much. So that's 360 minus theta for the reference angles. Now, let me show you some examples that they have. Figure 9. So this is 135. This is the reference angle, 45 degrees, 180 minus 35. Okay, here's a fourth quadrant angle. This is 300 degrees. So this is 60 degrees, 360 minus 300, if you want to go straight by formula. Third quadrant, this is 210. So this angle is 30 degrees, which is 210 minus 180. Here they have an angle of negative 45 degrees. That's okay. Negative 45 degrees. So the reference angle is still just 45 degrees. Okay. All right. Okay, now they give you all these different rules here. You can read them if you want to. I'm going to try to get you to the point where you don't have to memorize all these rules or, you know, figure out what's going on with all these rules. Just kind of reason it out. Look at your unit circle, okay, and use the tables that we had before. We are going to piggyback off this other table here also. It's still true. 30, 45, 60, and so on. Okay. Again, if we were meeting face-to-face, I'd make you memorize it, but be that as it may. Let's see what we can do with some of these now. All right. Sketch each angle in standard position and specify the reference angle. Okay. So let's try some of those. 1A is 110 degrees. Now you don't have to graph it that exactly. You don't need a protractor for this. You should at least get the correct quadrant. So it says 110 degrees. So where is 110 degrees? Standard position, you're always starting at the right. You know this is 90. This is 180. So 110 must be over here somewhere, okay? And just, you know, eyeball it. You don't have to make it that accurate, but it's definitely in the second quadrant. You know this is 90, 180, 270, 360. Right? And it says give the reference angle. The reference angle, take this ray, this is sometimes called a ray, okay, and come down to the x-axis. So what does this angle have to be? Hint, this is 180, this is 110. 180 minus 110, 70 degrees. Okay, now part B says negative 110. Negative 110, I go backwards 110. So that lands me over here, does it not? The mirror image, as it were. Negative 110. I guess you could also say that's going to be positive 250, I think it was, right? Yeah, positive 250. You don't have to write that down. Okay, so this is the reference angle. What is this reference angle? Just look at the symmetry. This is also 70 degrees. So here's my picture. So both 110 degrees and negative 110 degrees have the same reference angle of 70 degrees. Okay. All right, that's the way that one works. And I'll try for you, which one? Number 3. 200 and negative 200. Yeah, this one I better have 2 different pictures. 200. Okay, where is 200? Okay, we always start pointing to the right. How come? We said so. So that's 0. This is 90. This is 180. So 200 is a little bit more. So it's in quadrant 3. So the reference angle is this. How much is this? Hint, this is 180. This is 200. Subtract 200 minus 180, 20 degrees. Okay. Part B, negative 200. Well, I just do the mirror image. So B says negative 200. So negative means I start down or clockwise. So this is negative 90, negative 180, and a little bit more. All right, so I'm going to end up over here somewhere. Negative 200. So the reference angle is this. How much is this? Well, you can tell it's just a mirror image of this. It's also going to be 20 degrees. Right? So the reference angle is an angle between 0 and 90 degrees formed by the ray of the angle and the x-axis come down like so. Right, so that's quadrant 2, quadrant 3, and let me show you a quadrant 4 one, which is number 5. 300 degrees. Okay, I haven't been putting x and y that much, but you don't really need it. Okay, 300. We always start this way at 0, and I go counterclockwise for positive. So 90, 180, 270, and 300 is maybe like over here somewhere, right? $300 degrees. What's the reference angle? I take this ray and the x-axis as a ray, figure out this angle. So how much is this angle? Well, if I go all the way around, that's how many degrees? 360. This is 300. So how do I figure this out? Right? 360 minus 300. 60 degrees is my reference angle. Okay. All right, and they have the negative again. They like to have the negatives. Negative 300. So how do I go to negative 300? I just go backwards. Backwards means I start down. So negative 90. Okay, we always start to the right by convention. Negative 90, negative 180, negative 270. And so negative 300 is maybe here somewhere. And this is the reference angle. Can you guess what that would be? If I go all the way around backwards, that's negative 360. That's 300. So yeah, also 60 degrees. Okay, and yes, you may notice a pattern. 110 and negative 110 have the same reference angle. 200 and negative 200 degrees have the same reference angle. 300 and negative 300 have the same reference angle. That's true in general. Okay, that'll be true for most of the situations. Okay. All right. Let's see, what time is it? 9, 11, 13. Use the definitions, not a calculator, to evaluate the 6 trig functions of the angle. If the value is undefined, state this. Okay, so you have to just figure out where you're at and go from there. Okay, so let's see, 9, 11, and 13 and what you have to do. How about I will show you 13, because that's more than one revolution, right? 13. 540 degrees. Where is 540? Okay, if I go all the way around, that's 360. And if I go another 180, I'm at 540, right? So this is 1.5 revolutions. Okay. So if I crudely draw my unit circle, what is this as a point? Negative 1, 0. Okay. Okay. Cosine by definition, x coordinate. Sine by definition, y coordinate. Tangent we now know is y over x. Okay, so that's a new one. And see if I can show you that again quickly. Tangent of theta is y over x. Put it on your formula sheet if you wish. So y divided by x, 0 divided by negative 1, 0. And reciprocals, reciprocal of cosine, there's a co. Reciprocal does not have a co, secant. Reciprocal of sine, no co, therefore reciprocal has a co, cosecant. And tangent, cotangent. Okay, flip it. Reciprocal of negative 1, negative 1. Reciprocal of 0, that doesn't have any. So this is undefined. I'll just let you put a dash for undefined because it takes too much work to keep writing undefined. But sometimes the book and other books would put a dash. Okay, undefined. You must not put 0. 0 is not the same thing as undefined. You really want 1 over 0. And again, you can't take the reciprocal of that, so that's also undefined. Okay. All right. Now, how do you do 15 through 27? Use figure 8 to approximate within successive tenths the given trigonometric values, then use a calculator to approximate to the nearest hundredth. Okay, so if you have a calculator handy, you get it ready. So get my calculator ready, and I have to make sure I'm in degree mode. I just taught a calculus class where they were in radians. We'll get radians later, but I have to switch back to degrees now. Okay, so I'm in degrees. Okay, so I can quit back out. And let me make sure this other calculator is also in degrees. Yeah, we're in degrees here. Right, so what do they want me to do here? Guess the value from the chart, figure 8, and then use a calculator. Okay, so how about 15? Sine of 10 degrees, sine of negative 10 degrees. So how do I do that? Squiggly equal. Okay, so look at this. 10 degrees, y coordinate. Okay, so what's the y coordinate to the nearest 10th? Looks like it's 0.2, the y coordinate. If I had to go more, I would say maybe 0.19 or 18, right? 10 degrees, sine means y coordinate. So I'm going to say 0.2. And if I had to guess even more than that, maybe 0.18. Okay. Oops, I was supposed to do this one. My bad. Actually, it's not as bad as you might think. All I have to do is sneak in a negative in there. So, and then you don't know that I messed up. Put a negative there, negative there. I can tell by symmetry, right? By symmetry, if you look at negative 10 lands me at 350, doesn't it? I go back 10, I'm here. So what is the y coordinate there? The closest one is negative 0.2, and I'm going to say about negative 0.18. Okay. So that's what's happening. All right, now let's actually try it. So sine of 10 degrees. 0.173. Okay, close. I guess 0.18, couldn't tell. And sine of negative 10, negative 0.173. Every digit is exactly the same except for the minus sign. Okay, so the sine of an angle asks for the y coordinate. Let's do a cosine one. Oh, how about 23? Cosine 220, negative 220. Okay, cosine x coordinate. Okay, so 220 degrees. 220 is right here. X coordinate. It's kind of hard to gauge, but come up to here. Negative 0.8 roughly. Yeah, negative 0.8. If I had to get closer, maybe negative 0.75 or so. Okay, 220 degrees, X coordinate. Okay. I'm going with negative 0.8, and if I had to get even more careful, negative 0.75. Negative 220. Well, negative 220, I'm going backwards. Negative 90, negative 180. And then another 40 degrees. So I land here. That seems like it's going to have the same X coordinate, right? By symmetry. So I'll just put the same thing. Negative 0.8, negative 0.75 roughly. So that's what I would do if I was not allowed to use a calculator, but just read off the chart. Okay, so cosine, x coordinate, y, sine. The sine will give me the y coordinate. Okay, now let's see what it actually is. For the backwards type of calculator, I'll show it to you folks. So 220 cosine, negative 0.76. Okay, within the ballpark. Okay, so that's how you do that type of problem. All right. Okay, what time is it? I won't go that much longer. Okay, I don't have to finish the section, by the way. I still had time for it on Monday. And even if I'm still on schedule, which means I'm ahead because I haven't used up these buffer days yet. Okay, so that's how you do 15 through 23. 29 to 40, what do they want? Determine which quantity is larger. Then use the calculator to check the answer. For the calculator values rounded 2 decimal places. Which one is the larger value? Okay, so how do you do that? Okay, for some of them, it's like sine and cosine. Others, you have cosine and cosine or sine and sine, as the case may be, okay? So just by looking at the picture, 29, which is larger, sine of 70 degrees or cosine of 70 degrees? Okay, so we'll just eyeball it. $70 degrees. Cosine means x coordinate. X coordinate. 1, 2, maybe 0.35, I'm going to say. Cosine. Y coordinate. Well, it's almost way at the top, right? It's more than 0.9. I'm going to guess maybe 0.95, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So my guess is sine of 70 degrees is larger than cosine of 70 degrees. Right, that's all. Just look at what they got here. All right, and try it in a calculator, they say. So sine 70, 0.93994. Okay, yeah, that's pretty close to my guess. Cosine of 70, I'll show it on the backwards type of calculator. 70 cosine, 0.34, 0.35, yeah, pretty close. Okay, that's how you do that type of problem. Okay, and then similarly, they might give you the same, like cosine, cosine, or sine, sine. Let's do one of those, okay? How about 33, cosine 280 or cosine 290, which is the larger? Cosine 280, cosine 290. Okay, cosine is x coordinate. Okay, so use this. Cosine of theta is x, sine theta is y. Put it in your next formula sheet. If you had to memorize it, it's alphabetical. X is before y, cosine is before sine. Okay, so 280. Where is 280? It's way over here. X coordinate. 0.2, a little bit off. I'm going to call it maybe 0.18. And then 290, cosine of 290 is definitely further to the right. 0.35, something like that. So I'm going to say cosine of 290 is greater than cosine of 280. Okay. Again, you're looking at the x coordinate for cosine. So 280, a little bit less than 0.2. 290 looks like it's about 0.35. Okay, and let's actually check it out now. So cosine 290, 0.34. Close. And cosine 280, show it to you on this other calculator. 280 cosine 0.17, 0.18, yeah, pretty close. Okay. All right, I'll just do one more and it's almost noon and then we'll stop and I'll give you a quiz. And then you can break, as necessary. Okay, let me do one that has a negative and both signs. So 35, sine of 10, sine of negative 10 degrees. Okay. And now that we have a trig function called sine, a little bit of a timeout. From time to time, you might hear me spell out S-I-N-E as opposed to S-I-G-N. They're pronounced the same, right? So now it's ambiguous. Before you had trig, if I ask, what's the sine? Well, we never heard about this, right? So you know it means S-I-G-N. But now if I say, what's the sine? It's ambiguous. Are you talking about the trigonometric sign? This sign? Or the S-I-G-N meaning positive or negative. So if the context is not clear, you might hear me spell out S-I-N-E or S-I-G-N. So you might hear me even say something like, what is the S-I-G-N of the S-I-N-E? What is the sign of the sign, right? Because in English, they're pronounced exactly the same, right? So then I might have to spell it out. What is the S-I-G-N meaning positive or negative of the sine function S-I-N-E? Okay, so just give you a heads up on that. Okay, 10 degrees versus negative 10 degrees. Okay, sine of 10 degrees. Y coordinate, 0.2 or 0.18, I think is what I've been saying, right? Negative 10 degrees. Let's see, negative 10 is going down, it lands you at 350. It's negative 0.2 by symmetry, right? Negative 0.2 or negative 0.18 roughly. So which is larger? Sine of 10. So I'm going to say sine of 10 degrees is larger than the sine of negative 10 degrees, right? And let's check it out. Sine of 10, 0.17. Yeah, we seem to be getting the same numbers over and over, as you can probably guess. Okay, and the sine of negative 10. So on the backwards calculator, you have to hit 10 and then plus or minus button to get the negative 10 and then hit sine. Negative, the same thing, negative 0.173. So it works. Okay, we're done, folks. Anybody have a question? Otherwise, we'll go straight to the quiz rather than break. And you can break during the quiz if you want. Okay, quiz time. So put this away. Get your cell phones out. Or if you can do a screenshot, just do a screenshot. Okay, I'll raise it up here. Okay, solve the equation and round to the nearest hundredth. 3e to the x minus 4 equals 8. 6 natural log of x plus 5 equals 17. My hand's shaking, of course. I'm trying to raise it up so it's easier to see. Solve for x, round to the nearest hundredth. Okay, hint, how to get rid of an e with an ln, how to get rid of an ln with an e. Okay, so number 1, 3e to the x minus 4 equals 8. Number 2, 6 ln x plus 5 equals 17. My hint is to get rid of an e, you do an ln, and to get rid of an ln, you do an e. Okay, I'll hold it for maybe 10 more seconds, and then I'll put it away. I will stop recording also, since there's no reason to record after that. And I'll put you in your breakout groups, okay? And Star may come around to visit, other rooms. Your room will probably have 3, 4, or 5 people. Okay, I will assume everybody has it now, so I'll make this disappear. And go ahead and get started, and I'll set up your breakout rooms. Okay, and once again, put your first and last name and put the first and last name of everybody else in your group, please. I'll grade only one of them, so the only way to be sure to get full credit is for everybody to have the same thing. Okay, I'll stop recording.